Oh, everyone, GM. How are you doing
Good
today?
morning.
Ah, okay, we're still waiting for more people to join us.
Now, testing adults plays a crucial role in ensuring the quality and reliability of smart contracts. One, by thoroughly testing their code using a combination of unit tests, integration tests, end-to-end tests, regression tests, developers can identify and fix issues early in the development process, leading to a more robust and secure smart contract. When we refer to testing generally in the programming world, what we mean is you're trying to ensure the quality of your code and you're trying to simulate the behavior of your code at that particular point. Now, in simulating the behavior of your particular code, you can now see and even um, figure out or even realize there are certain flows that are not correct, certain issues that are wrong with your code at that particular point. So that's the role of tests and all that. And there are different types of tests. There's unit tests, integration tests, end-to-end tests. In terms of unit tests, we would see that later. But in terms of integration, it's more like a combination of your unit tests, like combination of different components, and then testing them together to see if they work as expected. End-to-end test is more like your system's functionality. You build your program, you test your program like from beginning to the end, and all. Regression, I believe regression is more like testing added functionality. So it just tries to see, okay, you added more functionality to your previous code and all, tries to like test them. But note will be focusing on unit tests. Yeah. Now, what are unit tests? They focus on testing individual functions or units of codes in isolation. When we say isolation, it means you're testing, you pick out each function or each unit of code inside of your smart contract and you test them one by one. You're not testing them in group. You begin to test them one by one. Typically using mock objects or stubs to simulate the behavior of dependencies. Unit tests in Hardhat are useful for verifying that each component of the smart contract behaves as expected. After compiling your contract, the next step is to write some tests to verify that they work as intended. The flow which we have been using to from creation to deployment of smart contracts is you write your code, you compile, and you deploy. But ideally, it's supposed to be you write your code, you compile, you test before deploying. So that's the ID flow we are supposed to follow. So as we said, it uses mock objects or stubs to simulate the behavior of dependencies. Since we are like testing in a it's not like in a real life scenario that the whole test is happening. It's happening in its own environment. So dependencies installed and all, you need to find a way to simulate them. That is, you're trying to like replicate these dependencies so your test can actually run. So that's where using mock objects or stubs comes in place. Yeah, any questions so far on unit test?
What is unit testing? Just to tests as we are going.
Yeah, so as you write your code, you like test them out. So you still use code to test it. You are not using, if you are trying to test in real life, what happens is you try to interact with it using a UI or something. But this time around, you are still going to make use of code to test your smart contract. So please let's take note of that. Okay, moving on to Mocha. Mocha is a popular JavaScript test framework. How many of us are familiar with test frameworks? Yeah, just Cypress. So Jest is quite popular. I believe Jest is like the most popular right now. So Jest is a very popular JavaScript framework. Cypress is also a popular um, framework, I believe. Yeah. So now we'll be looking at Mocha in specific. I believe Cypress is end to end, right? Yeah. So Cypress does end-to-end tests for, especially for JavaScript applications. Mocha is a popular JavaScript test framework used for testing JavaScript applications. So, when we talk about JavaScript applications, it could be your client side, that is your front end, or it could be on the server side, which is Node.js and or the same. So Mocha can help in, it's useful. It can be used in testing both on your browsers and also Node.js. So it provides a flexible and feature-rich environment for writing and running tests. What are the features of Mocha? Simple asynchronous testing. Mocha allows testing asynchronous code using callback functions or promises, making it suitable for testing applications that heavily rely on asynchronous operations. So when we talk about asynchronous operations in JavaScript, um, okay, let me throw it out to the floor. Who can explain asynchronous operations, especially those of us that are coming from that know JavaScript? Who has an understanding of asynchronous operations?
Okay. About simple application, it means you perform some function step by step.
Asynchronous, not synchronous.
Then, I mean, okay.
Okay, it is happening as well. So there's synchronous and there's asynchronous. Synchronous is when it happens step by step, one after each other. So if you write a line of code on line one, line two, line three, line four, well, line four, line five, what's going to happen is it's going to run line one, line two, line three, line four. That's synchronous. But when we talk about asynchronous, what we mean is like they run concurrently, they are run together. So in terms of JavaScript, most asynchronous codes are um, like promises and our callback functions. So where we have that's what, like if you want to actually dive into asynchronous, that's like a whole course and everything like that. But we can always go and research more about it. But just know in terms of asynchronous testing, Mocha allows us to do that. We also have versatile test structure. So it provides different interface for organizing tests, including describe, it. So I would like us to take note of these keywords because in writing tests, all these keywords are majorly used in writing your test and all. Now, what they help you to do is they help you to structure and control your test execution flow. So when we talk about describe is more like you're trying to group related tests or tasks together. So use that. So it actually takes in two parameters. One, what um the first one is a string where you like write the description of what is happening, and then the second one is a callback where you can now put all your individual tests inside. And then when we talk about it, it is describing. No, when we said yeah, when we talked about unit tests, we said is used to test individual functions and all. So use it the IT the keyword to write out your individual tests, like in isolation for each function. And then before it runs, that is, you're trying to say run this code before describe whatever is inside describe. is after, that is once the test is done, is the test inside your describe is done after runs, before each, that is before this individual test, the IT where you will see all of this in the practical session. Then we have multiple accession styles. Mocha supports various accession libraries such as Chai, giving developers flexibilities in choosing the accession style that best fits their preference and needs. So when we talk about accession libraries and styles, we're talking about tools that helps us to tools that helps us to okay, so in terms of accession style and libraries, to validate that conditions are true and all, we use accession styles to do that. So in writing out your test code, you'll be saying keywords like expect, should. So you're just trying to say, okay, this is the condition that this is supposed to meet at this particular point. So just like how we have our your if statement and all inside of your normal solidity file, where you use to validate and evaluate conditions to be true or false and all. So that's what accession libraries helps us to do. Jest has its own accession library. So whenever you're installing Jest, you see that its own accession library comes. Now, in terms of Mocha, they have accession libraries like Chive, which you can actually add to it, and it would helps you in your accession, that is trying to assert that, okay, this condition is true, this condition should be this condition should be that. Now, another feature is parallel testing. Mocha can run tests in parallel, enabling faster test execution, especially in scenarios with a large number of tests. So you can run multiple tests at the same time. Mocha allows that feature. Now we have reporters. It offers a wide range of reporters like spec, dot, nan, and more to display test results in different formats, providing clearer and more readable outputs. So you have the flexibility and the range of reporters to choose how to display your test results. So you can decide to display them in different formats. Mocha gives you that functionality. Another feature is the fact that it's extendable. So Mocha is highly extensible through plugins, allowing developers to integrate additional functionalities or customizations as needed. All right. So any question on the features of Mocha? Do we have any question? All right. Moving on. So how do we write these tests? The first step in writing your tests with Mocha is you create a test folder. So when we say directory, we mean folder, right? Create a test folder first. And within your other projects, create a dedicated directory for tests. Then this directory will store all your test files. Organizing tests in a separate folder ensures a clear structure for managing test suites and cases. I think if you take a look at Remix, especially for the default workspace, you should see like a folder named test, and then you see the name.spec.js also. Now, if you see that the tests are organized in the separate folder one, and they're organized in a structure which is clear and understandable. So you coming on to Remix for the first time, you actually see each test, and you can now specify that, okay, this test is for this, and you can navigate around each folder and all. So that is how to write your test with Mocha. You would create a test, a separate folder, and you can name it tests. And inside that folder, you can decide to probably create a new folder for each of your tests, or you can just list them out individually. That's how to write your test with Mocha. Now, another step and procedure you need to follow is you need to leverage Hardhat testing functionalities such as ITAS, ASAT, and Expect to interact with Ethereum networks and smart contracts within your test. Thirdly, you have to utilize libraries like ITA.js for contract deployments, function calls. I believe we know this at this particular point. And lastly, make assertions using libraries to validate the behavior, state changes, and outcomes of your smart contracts during testing. I've explained assertions, and we know assertions are used to evaluate conditions. Conditions if your code you are trying to test gives an expected outcome also. So all of this, you need to utilize them in order to write your test with Mocha. All right, thank you for listening and coming to our talk. So do you have any question? Mm, I believe you can, right? Yeah, I believe you can make use of some other. So you can just check other documentation, but I know primarily they support Mocha from the documentation. So you can just check that. All right, cool.
GM once again, everyone. Yeah, so this morning we want to talk about testing with Hardhat using Mocha, and it's very simple and straightforward. The code is on GitHub already. So when you open your, so let's start a new Hardhat project. What we're doing is that we're creating a new folder under training 18. We'll create a folder, then we name it practice.
All
So
right, cool.
once we
Don't see your
name
screen.
practice, we can, oh, let me share my screen. Okay. Okay, so we create a new folder called practice. And what we do now is that let me rename it. So what we do now is we navigate to that directory in our terminal. So for us to do that, we can just type cd, then training 18, then practice. When we navigate to that folder, the next thing is we run npx add that init, which is initialized. So create a new JavaScript project. We set the current root. Okay. So set the current root as a current folder. Let's try and press enter. Let's click on yes. So I'm going to wait a bit for the packages to install. But while it's still installing, you can see that we have some files and folder. As we all know, we have to check our Hardhat config. Then we have some basic setup already. But one thing is that we also need to install some other npm packages. But before then, we can just keep working with what we have. Okay. So what we do now is that look at the contract that we have earlier, which is this lock contract. This lock contract is basically a contract that allows you to deposit certain amount of funds Then after some time, you'll be able to withdraw it. So that's what this lock contract does basically. So now, how do we test that this contract is working the way it is meant to be? How do we ensure that there are no bugs in this code? Another thing again is that it can take time to test contracts without using tools like Mocha, because let's imagine you set that the withdrawal date should be 1 year in the future. How do you test that program will be able to execute after 1 year? How do you test? It's the only way you can do that is by using tools like Mocha that allows you to perform unit testing, and also you can change some parameters on your local blockchain, like the block number, like the current block timestamp. You can change those settings. So when you forward the block timestamp, you can see what will happen in 10, 20, and 100 years from now in your smart contract, and you will be able to ascertain that your smart contract works really well. Can you guys hear me very well?
Yes, we can.
Okay, thank you very much, King. So one thing you have to do now, let's create a new folder and name it a new file and name it under test folder. You can see I'm creating a new file under test folder. And that's very important because all our tests will be placed inside the test folder. So we can just, there's a default test that comes with the Hardhat package. So you have to you can just go through it or write your own test. But the test here is really great. It also gives you opportunity to learn how to test. Some things are possible while some are not possible. So you can check and also learn more from this sample code. It's about 126 lines of code. So, and it tests different conditions in this smart contract. So let's move forward and learn about the um, the way we can test. Under the test folder, let's create a new folder. Let's name it log test.ps. It's a different file. And also, if you scroll up to the codes, we've added some codes that you can also use to practice. So when you open the test folder, you can see we have log custom, which contains some sample codes that you can use to practice. The code is a bit simpler than what you get with Hardhat. It might not really be comprehensive, but like Hardhat, but it's really good for you to understand how testing works. We also added another custom test on that program, our favorite or popular story.js code. We added some simple tests for it already. So you can also check that one to understand how this testing works. So when you want to test, the first thing you have to import the testing library that I want to use, which is in Mocha by default. So what you can do is that you can import it. So when you go to the other dots, when you go to the log custom file or any of these test files, you should be able to see the package that we are importing. This Kai by default, it's is a way you can import the necessary libraries to be used in your testing. So we are going to import it. Once we import it, the next thing is for us to start describing what we want to do. So we can add a very simple test like this: describe. So when we describe something, it's telling the code I want to test, and what are you describing? Okay, you can see that in the default one, there's they pass two arguments. The first one they pass is the text, and also they pass a function which is a callback. So you can let me check this folder so I can show what I mean. Okay, you can see that in this describe you have two parameters. The first one is the text, just describing what you want to do. It can be anything. You can make it as long as you want. Then there's also a function that carries everything you want to test. So this describe is basically used to group similar test cases. So that's one thing you have to use, just for grouping similar test cases. You can see that we have multiple describe. It's not just only one describe. We have other describe. Describe deployment, describe withdrawals, describe transfers and stuff like that. We have different similar tests that have been grouped together. So when you check under this transfer, you can see that it's saying you should transfer funds to the owner. Then also when it comes to withdrawal, it's validating withdrawals. It should revert if it's the wrong account and stuff like that. It should fail if the time has not arrived and stuff. So those are some of the things you can test for. So when you have a test that looks similar, you can use describe to group them. So what do you want to test for? I want to test basically for how the contract will behave. So you can just say test log contract. You can name it anything you want, but don't you want test log contract. The next thing is a function that contains everything you want to do. Then you can now start testing. There are some basic terminologies and basic keywords that you have to be familiar with. We have it, we have before, we have before each. So one thing we can use before for is that before each test, you can run some code. So before all the tests or before each test. So the difference between before and before each is that this before runs before the old test, while before each runs before each of those tests. So if you have 100 tests and you have just one before in your code, that before will run only one time. It's like a constructor, just very similar to the way you run constructor. But before each will run every time your code runs. There's also after each. There's also after, maybe after your code runs, then you can run the another test. Maybe you have to verify something. Yeah. So let's move forward. The next thing we do now is that we define our before. So let's say before each test. So, sorry, it's not correct. So before each test, what we want to do is that we want to deploy. So before the test is not it's not before each, it's before the test. Before we start testing our contract, we want to deploy the contract first on our local environment. So deploy contract at first. So that's just the name. And the next thing is the asynchronous function. It's not like the one we have here. So it's going to be an asynchronous function. Then what we do now is that we now start talking about what we want to do. The first thing we have to do is that we have to use the ITAS library that I've been using from beginning of time to get the contract you want to deploy, then deploy it. And to that is very simple. If you come back to this code here, this log, any of these three code, you can see that we are trying to get the get contract factory. This get contract factory help you to load the contract. Then after that, you can now call on the deploy method on it so that it will now deploy the contract. Now let's do that. Const, you can say log contract is equal to, this asynchronous, you have to await it, you have to await it and say itas dot get contract factory. So it same thing you have here, get contract factory. It's here, and you can easily get it. I say contract factory. So yeah, once you get the contract factory, the next thing is go to your folder, a contract folder, and look at the name of the contract you want to test. In this case, it's log contract. So I'm going to copy it and paste it here and save. Okay, save it. Then the next thing is Let me go back to that contract again and look whether there is any parameter that needs to be passed to the constructor. So we have one parameter to be passed, but unfortunately, again, this contract also contains another keyword called payable. So we have to consider that one too in our code. So what we want to do now is that we can say lock contract.deploy. Assuming this contract doesn't have any constructor, this is enough. And an example of this is the storage contract. Let's look at the storage contract here. Look at the storage contract. There's no constructor there at all. There's nothing like there's not like constructor in the file. So when you go to the test folder, you can see that when we are deploying it, you just call on await storage.deploy, which does deploy the contract like that. It doesn't pass any parameter. So, but in this case, we are passing some parameters. And what are those parameters that we are passing? Scroll up to our log.so contract. We are passing the unlock time. When do we want to unlock the contract? So how do we get the time? That's another problem. How do we get the time in our test? There is a library for that. You can easily import it. It's called autonomic / Hardhat toolbox network helper. So from it, you can import the time and also other basic function that you can use in your test. So I'll just copy it from here and paste it in my code. So you can see that I have this in my code already. What I can do, I can remove the load fixture. We don't need fixture for now. We are still trying to understand the whole concept of Hardhat. So once we imported this time function, what we need to do is just to call it and say, okay, const, you can say current time is equal to, then you now say time dot latest, which is going to give you the latest time, but it's a promise, you have to await it. So you have to say await time dot latest, which is going to get the latest time for you. Then the next thing is, since the current time is just the current time we have now, we want the contract to unlock in the future. It's not, we don't want it to unlock now. So you have to say, okay, anything you get from the time, it's okay. Const unlock time is equal to current time plus how many seconds do you have in a minute? You have 60 seconds in a minute, 60 minutes. So what we do is that we can say 60 seconds times 60 minutes, which will give us the number of seconds in an hour. And because our timestamp for Solidity is always in seconds, so we be able to add the current time plus the number of seconds in the future. So you can say just a bracket 60 and 60 because of Bodmas and stuff like that. So just say 60 times 60. So this is going to add 1 hour to the current time. Then the next thing is you can now pass that unlock time to the deploy method. Then also you need to pass the amount of ether that you want to deposit, because this function, the constructor is payable by default. So let me check. The constructor for this one for this contract is payable. So we have to pass some ether to it. So what we want to do now is that I want to pass one ether. And how do we do that? We say ethers dot pass unit, which is the way we've been working with our ether so far. Then what unit do you want to pass? 1, comma. So this is going to get also 1 ether in way. So this is going to be an equivalent of 1 ether in way. And once you do all these processes, we are done with the deployment of our contract. So we are done with the deployment. And what you can do now is you can now run a simple command to test whether this thing actually works or not. So let's await this. Sorry, we need to await this. Is a promise. Yeah, let's await it. The next thing is that once you write your basic code, you can go to your terminal again and run this command npx Hardhat test. It's going to test all the code, and you can see that everything is working perfectly, nothing is failing. So let's assume that we added maybe like too much ether, which is a lot. Let's try to deploy and see whether we get any error. We are not getting any error, so let's try to continue what we are doing. And the next thing is this contract that we deploy, we are still going to be needing it in the future, right? So what we can do is that we can save it in a variable. You can say variable, then you can name it log. Yeah. So now after deploying the contract, you can now say the deployed contract like log is equal to await contract. So once you deploy it, it's going to store it here, and you can now start writing your individual test cases. The first one is it, which is individual test. So now we can say async function, and these are an async function. The next thing is, what do you want to test for? I want to test that, okay, the balance of the, okay, let's test for something simple first, so I do not get, let's look at what we can test for. What we can test for is that I want to check whether we can withdraw as of this moment. And we cannot withdraw because the current time is not up to 60 seconds yet. So it should fail. So it should fail while withdrawing because because of time. Yeah. So something like that. And you can just write any description you think it will be best for you. Let me try to, okay. Yeah, we have more space. What we can do now is that we can try to deploy this by, we can try to test this by saying, expect that, what are we expecting? We're expecting that when, if we try to say await log dot withdraw, yeah, it should fail. So one thing is that don't put await here, just say await this, then say to dot b dot reverted. What this means is that you are expecting that you expect this code to be reverted. So it's going to revert if it fails, and that's how it works basically. So let's try to test it again and see whether our test case works. So we are using code to test code. You can see that it succeeds. It actually succeed. It should fail while withdrawing because of time. That's one thing. It failed actually, but let's say not to be. Okay, to dot not be reverted. So we can say dot. It doesn't really matter the arrangement. What matter most is the last one, that they reverted or not reverted or stuff like that. So not to be reverted. If you try to test this now, that this thing should not be reverted, you see that there's an error because it's out of all the 10 test cases that we have, only 9 passed and 1 is failing. And that one that is failing is that expect transaction not to be reverted, but it's reverted with reason you cannot withdraw yet. That means that our contract is working the way it is meant to be working. And that's why when we are testing it, is passing. When your test is passing, that means your contract is working the way you want it to be. And also, if your test case is right, at times your test case might even be wrong. So you might be testing your code with the wrong code. So there might be a bug in your code, but because your test did not cover that bug, it will still pass, and you will think your contract is fine. So at times you need to use automated tools to test. But for writing this kind of test is still awesome. So you can say await expect that lock dot withdraw to be reverted. So that's it, because it's going to be reverted, and that's because the time is not, it's not yet ready, and so that's why it is reverting. Let's try to copy this same test case again. Then it should fail while withdrawing with reason. This time around, we don't want to use reverted alone. We want to use revert with, which is going to be, we need to set a message that, okay, what error message should it revert with? Your contract is reverting does not mean that what you want to do is actually working. Right now, we are expecting that this contract should fail because the time is not yet. So when you go and check your code now, when you want to try to withdraw, the first thing that checks is log.timestamp is greater than or equal to the unlock time, which means that if the unlock time is not ready, even though you are the owner, it's still going to throw an error. So it's going to be step by step checking. So right now, if you try to withdraw, it should revert with the fact that the time is not yet ready. So now let's just add a random text. You see that this text is random. It doesn't really mean anything. So let's see that whether this text will fail. I'm expecting it to fail, and the reason is because the smart contract didn't revert with this random text. It reverted that you can't withdraw. You can see that the error that we are getting is that assertion error. Expect transaction to be reverted with reason, blah 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 blah. But it's reverted with reason. You can't withdraw yet. Do you get it? So assuming that we go to our smart contract, we copy the right error, then we bring it back here, we replace this error, then we paste it here, then we save. You see that the error that we are expecting is that it should revert with you cannot withdraw yet. Let's try to run this error test again. You see that it's now passing now. 11 test is passing all through the whole contract, like from different files. It doesn't have to be only this file. So the next test case that we'll be adding is that let's assume that we find a way to fast forward the time. How do we know the time? Let's have a global variable that stores the time. Var, then we can say unlock time. So this is going to clash, but let's try to remove this so that we can store this unlock time in this variable and we can access it across different tests. What we'll do now is that we have the third test. Let's copy it. What we'll do is that it should fail. It should fail because you are not the owner. Oh, let's say it should succeed. Let's say it should succeed. If you fail this, but let's try to say it should succeed. It should successfully withdraw. Yeah. So yeah, for this thing to successfully withdraw, we have to meet what criteria? We have to meet two criteria in our contract, which is that the time must be yet, then also that the person trying to withdraw is the owner. So what we can do now is that we can try to fast forward the time using the time library. We can say await time dot increase to, then we should increase it to our unlock time. So it's going to fast forward the time in this our local environment to the unlock time. But you can see that while typing, there's another one called time dot increase. So when you say increase, it's going to increase by maybe 10 seconds, 20 seconds, the current time. Let's say the current time is let me say the current time is 100. Then you say fast forward, or let me say increase to 200. It's going to jump from that 100 to 200. But if you say increase 200, if the time is 100, it's going to increase it to 300. It's going to plus it with what you have currently. So that's the difference between increase to and increase. So what we can do now is that since we've increased, we are expecting that since the time is ripe and the owner of this contract is the one trying to withdraw, I'll still show you how to change the person interacting with this contract. But since we have the right owner and also the time has been fast forwarded to the time we specified earlier, it should not revert. it should not fail. So the contract should not fail, should not revert. So we expect this lockdown withdrawal to not be reverted or be not reverted anyhow you want it. It's just a program. It doesn't have to follow the grammar rule. So next thing is we can now test again and see what we have. You can see that it passed, it successfully withdraw. And that's because the time is right. Had it been within fast forward the time, it will not work. It will fail. Let me comment out this line of code that we used to fast forward the time and try to test again. I'm expecting it to fail. You see that it's failing. And the reason is because you cannot withdraw yet. Because of we fast forwarded the time, that's why we can test the code. I'm trying to check if people are with us. Okay, yeah. Any question? Question. Okay, yeah. So that's why it is. That's why it is working. Now let's now assume that we have another person. Let me call that second person Aka, and I will also have the owner. So we have Aka and owner. At the beginning of our class, I mentioned something that this before we run before every and before all the tests. It doesn't like repeat itself. It's only once. It's like a constructor. It's only once. So what you can do is that the moment you deploy this contract, you can also set the ACA and the owner. By default, when you try to deploy something, the first account is what will be selected. So, but you can switch it. So let me show you how to do that. Let's have a bracket line and say owner, comma, ACA is equal to Peters dot get signers, which is something the same thing we did there. So let's await it. We have to await it. Yeah. So it's something similar to what we have here. Let me show you from this file. Okay. You see, it's same thing we have here. We have this file. We try to get the signers, and we've done something like this before too in our previous classes where we connected to MetaMask to get list of accounts connected. But this time around, we are not using the browser environment. We are writing our code in Hardhat. We can still run the same meters.get signer, but it's going to return all the accounts that we listed in the hardhat.config.js. But if you notice, there is no account in our hardhat.config.js, and that's because we didn't set it up, right? If you set it up, if you set numerous account, like maybe you set account 1 to 100, in fact, you can use a passphrase like mnemonics to set your account. Then automatically you can have access to unlimited account in your other. Just try to change them based on what you need. So since we didn't set any account, it's going to use the default account that I told you. They are known as popularly known accounts. They are private key, and also everything is available publicly. So don't use this for real world applications. Don't use it for like a mainnet application. You can use it in testnet. You can use it in your environment, but don't use it for real world applications because anyone can access your contract and withdraw because they know the private key already. So now this account, we are getting two accounts, owner and ACA. Then we are setting it to this owner and ACA here. What we can do is that we can scroll down and say we want to have another kind of test that should fail because the owner is not who we want it to be. It should fail because the owner is okay, because it is not the owner, yeah, because it is not the owner, yeah. So yeah, something very simple. How do we now test that? Let me remove all the code inside this place. So what I would do is that I'll try to say, okay, this log contract to connect it to the hacker's account. Connect. So now this call is going to be made from the hacker's account, not from the owner's account. But if you say dot connect owner, this is going to be made for the owner's account. But if you notice one thing at the top of this page, that owner is the first one coming after the coming before the hacker. That means the owner is the default account, is the first account. So what we'll do is that we just switch it here that okay, connect now to hacker. You can switch it back to connect it to anything you want. So now we say expect that this thing should be reverted. So it should be reverted. To be reverted, we didn't specify that it should revert because of what? Okay, let's say to be reverted with what error message? Let's go and get the error message from the script. Okay, now it should revert with you are not the owner. So that's what's in our contract. Let's paste it here. So if it is successful, because we've switched the account to the hacker's account, so it should be reverted with you are not the owner, because hacker is not the owner of this contract. Let's now try to do that. This test should be successful. Oh, it's reverted with you cannot withdraw. Oh, sorry. And that was because we didn't fast forward the time yet. Let's try to fast forward the time because before we run the code. You know why it failed? It failed because it's going to check for the time before it checks for the owner. And since the time has not been fast forwarded yet, it's not going to work. It's going to throw the first error. And one thing is that once you fast forward the time, you you can you don't need to do it again. It's going to be like on that same time. So the difference between these two is that one is connecting with the hacker, one is connecting with the real users or the real owner account. Let's try to run that again. See that all the test case now passed. It should fail because it is not the owner, and it's because it is not the owner. If I change something like this, maybe you are not the. So if I do like this, I say it failed because it reverted with you are not the owner. Why I said oh, it should revert with you are not the. So that's why it is failing. That's how to run your basic tests, and there are more things you can do actually. If you also look at the second file in this storage.js directory, sorry, storage.js file, you can see that we have more tests like okay, should be equal to, should be this, should be that, should be this. So that's because we can also test for values. So let's do that ASAP. Let's have a new contract. Let's call it storage.so. I will copy my code from this folder. Let me copy it and paste it inside the new file. Let me save it. What I will do now is that I will start testing for some cases. Let me test for let me get the new file first. Then, as you know, we need to import our guy, which is so I want to import it. So this is it. Then we have to start describing our test case. Describe, you can say test storage contract. And the next thing is async. Sorry, it's a normal function. Function. Then we pass the normal function as a second argument. Then inside it, you can now have different tests, and also you can have before or before each. Before, before each of these contracts, before each of these tests, we want to do something. We want to deploy. Oh, so before the test, not before each of the tests. Before the old test, before the old, not before the old test. Okay. Then we can have our sync function. What we do is that we have to make some basic changes to say const storage contract is equal to, you remember, right? Await etas dot get contract factory. Then the name of the file you want to deploy, the name of the contract you want to deploy. How do you get it? Just come here. Let's scroll up. The name is storage. I will copy it. I will come back and put it here. Then I will save. The next thing is I should await the deployment. I'll wait storage contract dot deploy. And the reason we can do this is because there's no parameter with just normal. There's no constructor basically, and if there's a constructor, there's no parameter. So the next thing we can do is we can have individual test. It should test value. It should value should return 0 by default. Or let me say number should return 0 by default. Let's go and take our contract. These are in our contract, there's no constructor, nothing. What we have is just the store and the retrieve functions, and they didn't, by default, this number is 0, right? So if we deploy this contract and we test it first, the value stored must be 0 if it is working the way we expect it to be. So I say number should return 0 by default. Let's add our synchronous function. So when we add our synchronous function, what we can do is that we can say const. Okay, let me say. Okay, let's just say expect. Expect that. What are we expecting? We're expecting that when we test this contract, we say await this contract dot retrieve. The value retrieve should be 0. But we don't have the contract yet. What we can do is we can declare a global variable name is storage. You can say now that storage is equal to the deployed contract, the contract that we deployed here. You can say expect that storage dot retrieve to be equal to, let me say 0, because that's the default value. But one thing that this is a promise. You have to await it. So it's you have to await it basically. Then let's try to test and see whether it will revert. When we test, let's wait for it. It failed. And why did it fail? Oh, sorry, it's not equal, it's equal. So it's not equal to equal 0 to be equal 0. Yeah, let's try to do that. See that everything passed, and that's because the value equal to 0. But if you say the value should be equal to 1, that's where the problem will start, because it will fail because the value is not equal to 0 by default. So you see that it is working. And the main purpose of this thing is that once you write your smart contract and you also write the test, if you come back 10 years, 5 years, 4 years, 3 years, 2 months after, instead of testing everything all over and over again manually, you can just run all the tests and ensure that, oh, what my code is still working. And if there's any change in maybe API or something, or maybe even in Solidity, you get an error and you'll be able to fix it ASAP instead of testing manually. So this can really help you a lot since you write all your logic in down, and it can be reused over time. So this is just it 0. So this one should succeed. Then let's now work on that one again. Let's try to store something. Okay, should successfully store If you guys can see my screen, please send an emoji or you can send a text message. Yeah, King, can you see my screen? Oh, okay, thank you very much. So let's continue. So these are test cases that we're talking about. So we're trying to test whether we can store a particular number and it will not revert. So let's say store. If it is store, then say not to be reverted. Not to not be reverted, yeah. You have to await it. Remove this one. So just what value do you want to store? Let's say you want to store 10. Let's try to run this test case again. See, we number success. No, okay. So we successfully store a number. Okay. It should successfully store a number. Yeah, that sounds better. So it should successfully store a number. So we're able to successfully store a number. Let's try to store like -10 and see what error we will get. Okay, you can see that there's an error. Okay, value out of bound, meaning if you try to store a number that is not positive integer, you get an error, which is quite okay. So the next thing we also have to test for is that when we, after storing the number, then we try to retrieve again, what should the number be? Let's say it should successfully return 10, right? What we do is that we expect that if you await this call and say that it should retrieve the number stored, should be equal to be equal 10. This will fail. And you will see that it will fail because this is just an integer, it's not a big number. And the return value of a contract call, if it is an integer, should be in big number. And that's because JavaScript has limitation when it comes to number. They are the values you can store with integer. So now when you try to run this now, I'm expecting it to fail. Oh, actually, it works successfully. Let's try to check why it succeed. With story.retrieve to be equal to 10, let's say to be equal to 1 and see what will happen, whether it will still pass. Okay, it failed, and yeah. Okay, there's a difference between big number and number when compared and blah blah blah. But better actually, it's safer to just use big number. So you can just say it has just dot pass units, then say 10, comma, way. So it is an 10 way, and this one should work better. Let's just try to see what value we get. Okay, you see that it works. So this approach is better because you might want to test for an extremely large number, which JavaScript might not be able to support. So using this approach is far, far, far better than using numbers. So to test and also to retrieve your data. So now let's move forward and look at one more case. What other thing can we test here? Okay, we should we should write one more test based on what we've done before. I can just say we should fail. We should fail. Let me say it should fail. Fail to add bound number. Yeah. So we want this thing to fail intentionally and just to test that okay, our code works. and it will fail in real life too. If the person tries to include something that we don't really want. So let's say storage dot, is it dot store? Yeah, dot store. So what do you want to store? Let's say you want to store minus 10, then dot to be reverted. So we want this thing to be reverted, and let's await it. First thing is to revert. Let's try to test it and see. Oh, let's see. Okay, this kind of error is out of it's really like is not something you can cover with this test, because it's going to, it's not as if it is based on the smart contract error. It's like the ABI, because the ABI specifies that you have to pass u int while you are passing signed integer. So that's why it's failing, and you see that it's failing, and yeah. Let me try again to be fair. But this should also fail too. So let's just remove that kind of test. It's not worth it. And that's all for today. So I will be committing the code on our GitHub right now, so I can have access to it immediately. And also be uploading this video as soon as possible. Let me see. So if you have any question, please feel free to ask, and you can unmute now.